Good
Uh,
afternoon, everyone.
a very good afternoon to everyone. And I would like to welcome Dr. R. Sindhuja, who's a senior scientist at CSIR-Central Electrochemical Research Institute. And today she's going to talk to us on the topic emerging trends in engineering, artificial intelligence, and smart manufacturing. And this special public webinar is part of the school outreach program, which is jointly organized by the National Academy of Sciences India Delhi chapter and Deen Dayal Upadhyay College, University of Delhi, under the aegis of the DBT Star College program. So before inviting Dr. Sindhuja, let me briefly introduce her to all the attendees. So she has done her MS and Ph.D. in chemical engineering from University of South Carolina, USA, and has completed her B.Tech in chemical and electrochemical engineering from Center for Education, CSIR-Central Electrochemical Research Institute. After her doctorate degree, she worked as a Chemist Postdoctoral Fellow at Lawerence Berkeley National Lab at Berkeley, California. She has more than 4 years of industrial experience in the field of lithium-ion battery and its integration in electrical vehicles. She has worked as a researcher in India Science Lab of General Motors at Bangalore and worked as a manager at Mahindra Mahindra, Chennai. She is currently working as a senior scientist at CSIR-Central Electrochemical Research Institute, Karaikudi, and is also an assistant professor in CSIR's academic and assistant professor in chemical engineering at CFE, CSIR-CECRI since December 2017. She has been part of the technical team that helped draft the faster adoption of manufacturing of hybrid and electrical vehicles in India and has around 11 publications to her name. She has managed 4 individual research projects and part of 2 major developmental projects, and is also a member of technical committees of Bureau of Indian Standards. With these words, I now invite Dr. Sindhuja to kindly share her screen and deliver her talk.
Thank you, Professor Saxena. I would just stop my video and then share my screen, if that, with your permission.
Sure, please.
Good afternoon, everyone, and welcome to this session on emerging trends in engineering, artificial intelligence, and smart manufacturing. And as Professor Saxena introduced, I'm Dr. Sindhuja. I work as a senior scientist and computer networking unit of CSIR-CECRI. So before we go into the topic, I thought I'll just start with where the evolution of technology begins for us. I'll just give you a historic perspective so that it helps us connect with where we are today, from where we started. When we started, we all know that mankind started with making tools with hands. So with whatever was available in the prehistoric age, they started making tools with stone. And that time, the source of power was fire. And we were all hunters and we were nomads. We were not settling at that point in time. Slowly, this technology evolved as we progressed through prehistoric time to bronze and iron age, where we started making use of tools that we made to make further technological development. We started with simple manufacturing process like smelting. And again, the source of power in this age was again fire. And we went with making simple tools, and we started making settlements, and we also started agriculture. As time progressed, we further progressed using all the tools that were available to us, and we started the systematic urban manufacturing in the Middle and Renaissance ages, where simple tools like a printing press and fulcrum was used to carry items with us. So as you can see, the power and the knowledge, the scientific knowledge that we had of making power helped us make technology in the next era. And that technology, we further progressed to doing much more advanced engineering. Now we come into the era of industrial revolution. The first industrial revolution, as we all know, started with a steam engine. So we had fire, a knowledge of making fire. We combined it with water, and then we produced steam. And we use that knowledge to convert into a technology like a steam engine. So that led to the mechanical production. And the skills that were needed at that point was working with tools and machines. So the first few cycles took like almost a century to half a century. So we got from the first revolution of industrial revolution to the second one nearly half a century. And that started the process because of discovery of electricity. Now we use the water and we use the steam and we produced electricity, and that led to mass production. We used the electricity that was produced and our own knowledge of making tools, simple machines, and then integrated that into a factory. The first major industrial revolution started when we started putting all the machines together, when we put integrated machines, which we call as assembly of machines. So again, just to give you a perspective, we started with our knowledge of fire. From that, we made use of whatever was available to us, stone, iron, or metals, and then made tools from that. During the prehistoric and metal age, like the iron and bronze age, from that we made simple equipments, and we use those equipment to further develop the engineering. And we started with the industrial revolution when we found steam or steam engine. With that steam, we further went on to produce electricity, and that led to the mass production. And that mass production, we got the skill of integrating equipments together, the machine together, to make an assembly. So that was the real industrial revolution. From that on, we further moved of 30 to 40 years of that, and then with the start of internet, electronics, and computing power, as the computing power developed, as a computer was widespread availability was done, then we moved on to the third industrial revolution. For this, the driving source was, as I said, development in semiconducting industry, internet, and the computing power. And this led to industrial automation. So our industries became more robotic driven, and that led to an industrial automation. And in this kind of a field, what we needed was we needed the skill to operate industrial robots, or the machines that made the products. And we needed to understand how the assembly of equipments worked. And we needed some digital skills, like we needed to know how a computer operates. We needed to know the programming languages. So this era was mostly a program based computing tool was used, and we got into a stage of precision engineering. Like we could make products with up to a nanometer of precision. So that kind of a precision we could get it. And this, again, with all of this, now at present we have moved on to the industrial 4. I mean, in Europe and US, this has been there since the beginning of this century. We are India, we are getting into this, we have gotten into this recently, and this is getting a widespread of acceptance now. So what led to this industry 4 or current trend of manufacturing in engineering is a lot of technologies have come together, mainly the culmination of cyber physical systems. So what are cyber physical systems? These are actual physical systems. When combined with digital technology, they give us a tool or a set of tools that can be used for many different purposes. For example, at your house, you have a smart technology, you have a physical switch, which you can ask Alexa or another tool to just switch it on or switch it off. So this is a simple example where you can think of a cyber physical system. The physical system in this case is your switch, and you have the intelligence or the sensors and all the other components are built into another device that talks to the physical system. That means you are asking a switch to be switched on, it does the job. So that part is the digital part or the cyber part. Now, when it comes to the industrial technology, all of this, in addition to the robotics and the automated parts that we had in the third revolution, all of them put together gave us something known as the industry 4, or the current industrial revolution. So what are all the driving forces for this is the advanced manufacturing technique. We will talk about each of this in a minute. And the robotics, and again, it's not the simple robot arms that was used for automation in the third industrial revolution. Here the robots also have some kind of an intelligence built into it. And IoT, what is known as Internet of Things, and artificial intelligent tools. All of this, when it was brought together, gave rise to what is known as Industry 4 or smart manufacturing. Now, what does this really lead to? It leads to automation, and the degree of automation is larger compared to what we had before. And there was a lot of data exchange that is happening because of all the connected devices. And this leads to smarter, intelligent manufacturing. And all of the processes being digitized. So this industrial revolution needs a different kind of skill sets. It does not just need the mechanical background that you had before or a computer knowledge separately. You need an integrated or multidisciplinary skill set. For each of you, if you are just good in one, it may not work as you go further. You will have to develop a multidisciplinary skills as you grow along. As a student, this has now become a necessity for you. And also and when you go into industrial revolution 4, it also needs deeper understanding of working of machine. If you're going to make machines that are intelligent, then we need to know how the machines work. And also we need to know how human intelligence works. Only then we will be able to get the intended output from that. Suppose I want to make a spear part, and then I go about it as a human being, shaping it and designing it in certain way. But if I ask the robot, which only knows how to design a cube, I can only put the length, width, and thickness for it, and I ask the robot to design it. It's not going to come out right. So I need to understand how the robot arm works. I need to know how the curvature is built in and all of that. And I need to tell the robot how to adapt to the shape that I want to. So all of the deeper understanding of how the machine works and how we as a human being think, or how do we really design something, how do we build something, and once it is built, how do we test. And each stage, all our intelligence and all our knowledge has to be correctly translated to the machine and how it will operate. So that knowledge, deeper understanding of both, and then translating of that information to what is needed is the real skill set. And that is where most of the human resource is going to be employed. It may not be actually employed in making the parts or making any product per se as you go along. Our usage, a skill set is going to be more of how to operate the robots and how do we really make the robots more intelligent or make the machines more intelligent. And we need to also develop all the skills, all the digital tools, whether it be the computing tools or the cyber physical systems that are to be there. All of this have to be built by us as the progressive industrial growth happens. And most of these tools are already available in most part of the globe. We are just catching up with what is there out. Now, why is this digitally aided manufacturing needed, and how does it really work? I mean, as a student, probably you are used to buying things by now through online systems. You go to a system like Amazon or Flipkart, you just order something. Say, for example, I want to order a laptop. Now I order that, and what does the how does the system work? So it transmits your ordering information for the particular product to one of their centralized data system, and they check it with their digital inventory. So they have the inventory of what is available in a warehouse. Probably you are in a city like Mumbai, and they would have hundreds of warehouses there. And once you order, it will keep checking which is the nearest warehouse to you, and is that product available, and is it as per your specification. Once you is identified if it is available, it's going to ship to you immediately. So that is how the digital platforms work, and most of us have some kind of a knowledge about this. But what happens if that product is not there? Today, we'll have somebody has to go and raise an order for that, and they have to say this specification, and then it will have to be translated to a factory, and that factory might be either some part of India, or it might be even somewhere outside India. So all of this information has to be given to them, and they will again start making the product. But what happens if you connect all of them digitally now? So you are making the process more adaptive and flexible. For example, I need a certain specification of a laptop XY. I've given it, and they found that it's not available in a digital inventory. It's going to say that send the specification to the manufacturing plant, and the manufacturing is going to start, and it immediately send you the availability. There is also another thing that can be done now. There is a constant updation of availability and demand. Sometimes there, because when your schools or colleges are starting, the demand is going to be higher at that time. So once, if that information is already available to the manufacturing agency or the plant, they will rapidly produce it, or they will increase the rate of production. They will have enough availability of all the materials, starting from the raw material till the product. They will have everything planned according to the demand. And when there is going to be no order, say during the middle of the year, probably the number of items that is going to be ordered is going to be less. Now, if this information is constantly being updated from the digital inventory and the place that is being manufactured, then the whole process of manufacture becomes adaptable, and it's also flexible, and it can be automated. It not necessary that somebody has to sit and enter all these details. A demand is raised, immediately the system checks the availability. If not, it sends a trigger, and much more intelligence can also be built into it. Now, if you can predict, say this is the duration when the demand is going to be higher, based on all the knowledge collected, prior knowledge collected, then the manufacturing process can be planned and easily executed. So that is the advantage of going into a smart manufacturing. Now, how does a factory, a smart factory looks like? That is the process of talking about when to start the manufacturing, and what happens at the demand and supply side thing. But what happens inside the factory itself? The picture that I'm showing you here is an example of Siemens factory. And I've just put it for a certain cartoon here, just for us to understand how these systems talk. So all of the process talk to each other and digitally. That means it sends some signal for this is the starting process. It's going to say, this is the starting process. It's going to state that I'm going to start the process. It's going to send a signal at I need 10 parts in an interval of 1 per minute. Again, it will send these information digitally. There will be codes for each of them saying these are the number of parts needed. Each part will have its own identification numbers, and it will say at what time does it need it. All this information is sent to all the connected equipments. For example, this is the equipment where the process is going to be, sorry. This is the equipment that's going to start the production. Then the supply of material is going to be from this. This equipment is going to supply all the parts that has to be put together here. That means once it sends the signal, this will start transporting the parts, say 10 number of parts, 1 per minute. So 1 part per minute, it will keep on sending it here. So there has to be a communication link between both this equipment. And it's like there might be hundreds of such parts connected in a factory, in a larger factory. So each of them has to have a mechanism for transferring information at the to each other, and they have to talk to each other. That's what it's in a colloquial way. When we say it, we say it has to talk to each other. That is just sharing the information digitally. And now once this is produce the parts, there has to be another mechanism where the parts have to be collected and shipped. So this also should need to get that information, saying I'll get ready in 10 minutes to pack the 10 parts. So this is how an interconnected and a smart factory design will look like. So there has to be a seamless connection of all the individual production steps. It has to start from planning stage till the end. I mean, this just means that it is the field, the person who is going to ship it, or it, again, that could be an automation. Now, the degree of automation can be different from each factory, and it depends on what is really needed for the specific factories. What is the advantage of this kind of a approach? Now, you will, once you know the demand, you can start producing it at the rate you want to, and also it will reduce the error. This equipment usage will also be limited. It will be used only when it is really needed to be used. All the time, the power consumption and everything associated with each of this equipment is conserved. So nowadays we are talking about energy conservation, resource conservation so much that this is really a necessity for all of us. So for example, you are going to go into a larger factory. What we probably even at our level of our own house, we see that when we don't really need an equipment to be on, when we switch it on, we are unnecessarily consuming energy, electrical energy, and also we are wearing out the equipment. So in factory, this is even more worse, because you don't really want to use the equipment unless it is really needed. So all this connected technologies will help us optimize, will help us use each of the resource available to us, whether it be the raw material or the equipment itself, only when and if it is needed. Now I'm just going to give a bit more details of how a smart factory floor will look like, just for you to understand this whole thing. So the connected equipments run the manufacturing process. As I said, each equipment will send a signal to the other, the next one, or whichever equipment it's going to affect. If it can be the equipment before or after, whichever one it's going to affect, it's going to send certain signals to start or stop. So once the products are coming, robots will handle them. Robots will handle the parts. If it's being made, the part will be picked up and dropped by a robotic arm. When we say a robot in an industrial setting, typically it is a robotic arm that handles it. It may not be real robot android or something that's moving along. It is just a robotic arm that is picking up and putting the things in its place. There will be sensors at each location so that the movement of the parts will be monitored, and also there will be at places where you need, there will be quality checks. For example, you are sending in a product and you want to know if there are any defects here. So there might be a camera at this point where it will take a picture of that part coming out. It will send to us computer where it will be analyzed if the part is at as you need it. You are going to produce a box and it has to have a shape of a certain dimension. So for some reason, this equipment is malfunctioning, so it is not working as needed. There is a defect in this part. So instead of allowing it to all the way going to the end and then finding out that there is a mistake, what will happen is it will check it. As soon as it detects that there is a change in the size, or there is a hole in the product that is being made, it will stop the process, allow somebody to correct it, or there can also be an automatic correction if the degree of automation is too much. Or you can have a man or a human being here stop it and then ask them to look into the issue where the defect is being coming through. Now the last, and also all of the whether it be raw material and or the finished good, robotic can be the one who's handling it. So human intervention could be minimum, except that they would monitor how the robots are behaving and how are they doing the right part. Once the product is finished, using barcode or another tracking technology, they would just ship it, and then it is tracked all through. So another way of looking at it is where all this smart features can be used in an in engineering setup is while you're actually designing and visualizing the product. So you use a lot of equipment, a lot of things around you. You use laptop, mobiles, you have a lot of devices with you, and many household items. So all of them is being designed at a factory or a manufacturing plant and then being made. So this designing of the product itself, and during the design you will have to visualize, anybody who is designing it will have to see how the product is going to come. If you actually design and then make it without understanding how the product is going to be, you will spend lot of money. The whole thing would have been produced, say hundreds of the product would be produced, and you the company will find that it is not as per their need. That case, a visualizing tool at the start of designing, like an augmented reality based technology, will really help in minimizing lot of errors, and also give you a benefit of seeing how the product will be handled by the users themselves. For example, today you have user centric design being done. So I'm going to be the one who is designing a mobile phone. So I will look into all the aspects that a user will use it. So is it really pleasing? Is it the weight? Is it too much? Or what happens if the user drops the phone at multiple times? How will that affect my product? So all of those aspects, I can visualize it while I'm designing itself, and then give a right product. And then the next part that I talked about briefly is the material management. So the sensors will help us at each point say how each material in the process it is being made. So you have a plastic that is going to be molded now. Just think of that as an example. A plastic cover has to be molded. It's had to be made it in the shape you want it. So that is the whole process. So the raw material that is needed has to move through this equipment, and it has to go through a molding unit which shapes it, which just gives shapes it and then sends it out. So the material movement, both of the raw material, there might be 2 or 3 materials mixed together to get the end product. So all of them have to move correctly, because it is not now human beings who are moving it. So it is going to be robotic movement. Then each of them has to be synchronized. You otherwise it will be a waste of the whole process. You send in one material A, and for chemical, let's assume that there is A and B that has to be mixed to get the product. Now you send in A at one rate and you send in B at another rate. That means you are not going to get a correct product. So all of this material management has to be done. For that we use something like a smart sensors, and this whole process also has to be designed properly. Now, and next, when it comes to the next one, is known as adaptive manufacturing. This is one of the real benefit of a smart manufacturing. Earlier in the third industrial revolution, and even today to greater extent in India, the factory lines are set. So if I want to make 1,000 parts, my line will be designed in such a way that I can make only 1,000 numbers of something. I cannot reduce it or I cannot increase it. My equipment is not designed in those ways. But if I have a modular equipment which can change the size of how we want to do it. For example, I will need to make a box 10 cross 10. Now, with the same equipment, I cannot make a box of say 15 cross 15 unless I can change it. That's just a simple example. So if you have modular equipments, that also becomes a part of smart manufacturing. The whole setup is now you can use the same assembly lines or the same set of plant to make different products of different sizes or even different makes. That saves a lot of cost when it comes to manufacturing. So that gives us a advantage of using it adaptive manufacturing. Now, another important factor in large scale manufacturing is the quality control. How good is your product? Now, all of us are aware of quality of each product. It's not like before when we would buy a product and we'll see it fails in 2 days. Now we go through a lot of review pages. We look into what people say and probably in different countries or what your friends say. And then based on that, we buy things. So in that when that factor is taken into account, for each company, it becomes more advantageous when a quality control is ensured. For that, you can have, as I said, you can either keep a computer, or there are different technologies for different products. Say a computer visualizes it and it sees if the product has any defect or if the product is in the same color that you want it. Suppose somebody has ordered a black mobile phone and then it comes out in red. That means it's not what they want and that product is not going to be bought. It's a waste. So there you will have a quality check, and those are all mostly now controlled by a computer or a digital technology. And one more important thing that has to be is there in the part of smart manufacturing is the preventive maintenance. All this aspect is for our users perspective, but for the manufacturers themselves, they do not want any equipment to fail suddenly. You can imagine when you have you're depending on something for in your house to work and suddenly it fails. So we can understand how difficult would it be for us. We are expecting a pen to write as and when we want it. It is not working, then we have issue. So in the same similar manner, when it comes to an industry, they expect each piece of the equipment to be working perfectly. They do not want it to fail. So in that case, a preventive maintenance is also done nowadays using analytics. So they take care of the they get data from each equipment and see if it is working like it should be. If it is not, then they stop it and then they do a preventive maintenance rather than the machine failing without giving any warning. This is a planned maintenance, so they can do it in the time when they don't have any product to be produced. So they have an off day holidays, or whenever they don't want to produce anything, they stop it, do a preventive maintenance. And for that, they have sensors that monitor the working of each of these equipments themselves. So that is one aspect of a smart factory. And each of them is again helped by a lot of digital tools. We'll come to that in a minute. And the last part is something that we are all familiar with, is the shipment of the product. And we know it is all now tracked, so that the minute it is shipped, you are getting an SMS or you're getting an email saying that your product has been shipped. So all of this is because of the tracking technology that has been there. And the last one is also being nowadays adapted is wearables. So the person who is transporting your products might have a tracking device in the watch or something, where that is also being tracked. Or the product could actually have a sensor. If it is an expensive product, the box itself could have a small sensor inbuilt to it. So it will keep on tracking, and then you will know which place is the product available. Now that all of this shipment happens across globe. Now, so just to put a bigger picture, what are all the aspects to an industry 4? So when we talk about Industry 4, it's talking about a physical and digital connected system or a cyber physical system. So there are multiple technologies that have come together or that are used in synchronized manner to get what we need. So what are all those technologies? We will start with augmented reality, additive manufacturing, simulation, Internet of Things, big data analytics, cloud computing, cyber security. And I will not talk too much about this horizontal and vertical integration. It's morely part of management. And the last one is robotics. So as I said, it really needs a multidisciplinary approach, whether you're thinking of entering into an industry at some point, or if um, you think of just understanding it, you can think that this is a really a multidisciplinary approach. It cannot be that I'm only know something about additive manufacturing and I don't know how this process is integrated with a sensor. So if I do not have at least an overview of that, then I will not be able to design the product properly, or I will not be able to work effectively. So I need to have a multidisciplinary approach and a deeper understanding for each of this. So the first thing that we will start is the augmented reality. So most of you have seen the virtual reality, like you would have played games, and you would have even, some of you might have even thought about playing an augmented reality games. So you have a goggles on where you can see a two-dimensional image into it, comes up into a screen as a 3D thing, or sometimes even with a extra information to tell. It tells you all the information when you look through the goggle. So this is really helpful when the designing the product or designing the robots. And mostly that is used when they are controlling the robots inside the factory itself. They want to understand how each part moves. So instead of going in the plant and then seeing it, even some of the parts you cannot even see if you really go into the plant. So in those cases, visualizing it using an augmented reality platform gives them an understanding of how each of them move and how each of them physically interact with each other. So, for example, what you see here is this engineer is trying to manipulate a arm, or he's trying to understand how this robot's arm is moving. So he has all the information related to that affects this robot's movement. It could be that the robot movement will have to be synchronized with what is it is picking up. This could be picking up an object, so it needs to know the shape of the object. It needs to know what is the height, and it also needs to know if there is something else in its way. If there is another equipment close to it, you cannot just move it as you want. It has to know what is connected to that. So all of this information is translated to through this augmented reality platform. So a human being can actually understand how this movement has to happen. So as I said, this will really help in designing the robots and designing the product that they are going to make using this technology. So how this augmented reality actually works is, as a definition, if you have to see, it says a combination of real and virtual worlds. So what it really does, it takes a video or a photograph of the object, and then it superimposes all the images to give you a three-dimensional computer generated video. And this is the augmented layers, and it also has digital information. Just as I said, it also, it not just gives you a three-dimensional view of this, it also tells you all the information that affects this particular part. So this is a kind of a advanced technology where the robotics design and operation is actually controlled. Another technology that is helping and developing the smart manufacturing is the additive manufacturing, or sometimes known as 3D printing. As you can see, this is a 3D printer of a plastic here, and the main advantage of using additive manufacturing is you can make shapes of your own desire, and you can make them in the way you want it to be. Nowadays, we are commonly using 3D plastic printers to make smaller objects and toys, but this is not just restricted to that. You can even make dental implants and complex objects like heat exchangers, and even lithium ion micro batteries are made today using additive manufacturing. So it has a lot of application. Today it is not too widespread because there are a lot of technological advancement that has to be made, and it's a bit expensive. So this is used only when you need parts of certain shapes, because making the components like this in a traditional manufacturing is near to impossible. Whereas in an additive manufacturing, you can make as small as you want, or you can make shapes of your own design. So all of that is possible. So in future, this technology will be getting to this will get excuse me, this will be more prevalent across the industry. And to understand how the additive manufacturing works, it prints, or it deposits the layer, each layer on top of it, and there is a CAD or three-dimensional design for each material that has to be made, and the material is chosen, and the robotic arms or the tip that moves, it takes up the material according to the design, and then by each layer by layer, it deposits and makes the shape that you want. Now, what is the main advantage of additive manufacturing when it compared to conventional manufacturing is, in a conventional way, the normal way, the material is taken and it takes out the shapes that you do not want. It is not the reverse. You take up a material in the larger scale, and it takes off the material you do not want, and then get the 3D shape that you want to make. I'm just comparing if you have to make the same material using a normal method and or a subtractive method and additive method. That means you have a lot of wastage. Whereas in the additive manufacturing, you do not start with a shape, a regular shape. You start with the material, and then you layer by layer it is deposited to get this shape. So only little wastage is there, and that too it can be avoided to a greater extent if the system is optimized. And this is very important in today's world, because we want to have a conservative approach to materials. So the next aspect is something that has been there for a while, which is the computer-aided models and its simulation. So you can have an entire simulation of working of a plant, or you can have a simulation of one simple component that you want to make. All of this information is developed into a model which tells you how the component is going to be made, how the component is going to be moving from one place to other, and how it is going to work. And this helps in the trial and error approach. It avoids that, and then it helps in the manufacturing process. So the next important feature, which really has given a lot of boost to the smart manufacturing, is the sensors in the connected device, or the IoT, what is known as IoT, or Internet of Things. Here I'm not going to really talk about what an IoT per se is. I'll just give you a brief understanding for that. In the industrial setup, industrial IoT, any technology, any sensors, or any connected device that really helps in instrumentation and control of sensors. And these devices have to engage cloud technologies. What it really means is, I have an equipment and it has a sensor built in. It says how the parts are moving. So that information is given to the quality control equipment, which really controls how fast the equipment should move, or how should the material move. And instrumentation part, how should I pick up the material, how should I in the robotic arm, how quickly should it pick it up,
Is the material close to the arm or is it far away? All of this information is conveyed through the sensor, and it is connected to cloud technology. It is not in the system. It could actually be in a local system which monitors all this, but what really makes it smart is all of this information is transferred to a computer, a network through the internet, so that the material movement is globally known. So it is not smart sensors and is already there in most of the automated systems nowadays. But what makes it smart is all this information is clubbed with the cloud technology. That is the important aspect that has driven the smart manufacturing. So now, what are all the technology behind IoT? As I said, it has now it is access to low cost, low power sensor technology is one of it, and connectivity is the second aspect that is driving it. And it is all the information through the cloud computing platform. It takes up and makes use of all the information. So all the other things we will see in a minute: machine learning and the artificial intelligence. How does this link for smart manufacturing? So when it comes to engineering aspect, what is big data and why do we really need it? All of the information, as I said, are collected from the IoTs, it's transferred to a network, through the network to a system where it is all the data is collected, and it's all of this data, a large number of data is collection of this is known as the big data, and this data is analyzed using computing tools, and there are different aspects and different purpose for this data analytics tools. And so anything that helps, any tool that makes sense of the data collected, because without making sense of it, all this data is useless. So you want to really understand what is happening. So all of this data has to be analyzed, and this computing tools put together is known as the data analytics. In that itself, there are 4 different purposes. Again, I'll just tell you the brief thing about it. Why do we really need this tool? One is the descriptive type of analysis. This tells us what happened. So you collected a data, you know that machine has failed. So this information helps you understand what had really happened. Why did this machine fail? Another one is the diagnostic analysis. You have said what has failed, and then you need to know why this thing has failed. So this diagnostic tool, each of them has its own unique inherent qualities, which we will not really go deeper into. And the main thing is here only the insight into past performance is taken. Here you are trying to understand the anomalies, trying to understand what is the difference, so that you can understand why this thing has happened. The third one is, which is more important for an industry perspective, is predictive analytics. So it's going to say, based on what I have before, I will answer question, what is going to happen if I'm going to use the same equipment 10 more times, what is going to happen? So that kind of an analysis will give you the those tools are known as the predictive analytics tools. And there are different techniques that are used along for this. The last one is the prescriptive analytics. You know what has happened, why it has happened, and you also know if I keep using the same equipment, what is going to happen in the future. So now I have to give a prescription so that if this equipment does not fail, if it has failed 10 times the past year, and I know why this has failed, now I will say that if I'm going to use it 6 more months, the same thing, this is what is going to happen. I know that information. Now with that information, I should be able to take prescriptive analysis so that it does not fail again during the next 6 months. So that is the connection between each of these tools. And we talked about the analytical tools, but what are all the techniques that is driving this is the generally known as artificial intelligence. So what it really means is any computing tool that has intelligence equivalent to human being. So if I look at a problem and try to analyze it, can a computer also look at the same problem and analyze it the same way? So if such a technique is available, then that tool is simply known as artificial intelligence. And there are subsets to it. Something talked about nowadays is the machine learning. This is a subset of artificial intelligence, and this enables the machine to improve. So it is doing any repeated task, and it enables the machine to do the task much better. So that kind of a tool is the subset of artificial intelligence, is known as the machine learning. And again, there is one more subset to this. This is the deep learning, typically known as neural networks. It has been used quite some time now. So it really trains the machine to perform a task much better. So if you look at all of this, each layer has an advanced feature built onto each other. This is the broader term. A subset of that is the machine learning, and a subset of machine learning is a deep learning tool. When it comes to manufacturing, the main objective of using any AI tool is to have a predictive maintenance, as I said before, and we want the environment to be safe. So if I know that there is a temperature increase somewhere in the factory, and I don't want something to happen, then if I have that information and if I can analyze it, then I can do something about it and keep the environment safe. I don't want temperature to shoot above what is normally okay for a human being. There are many other safety aspects also. So all of those, if I have the relevant data, I can have a safer environment. Again, and the last one, the third one is the human robot collaboration. So how should a human control a robot, and how to understand all of this? Again, it's done through an artificial intelligence tool. The one thing that I've already talked about is the quality. So how do I ensure the quality? I use the data from the sensors, use an analytical tool to understand it, and then improve the quality. Then the cost optimization, if I want to operate only during certain time. For all of this, I use artificial intelligence relevant tool. Now, this the information collected from the sensors or the IoTs is actually taken up using a cloud computing platform, and that is where it is analyzed, and it's also stored there. So what is a cloud computing? It's nothing but all of the computing tools, like a server where your data is stored, a database, network, software. It's like a system on the internet. If you can think of it, it's like a computer on the internet. It doesn't matter if the physical system is there in the factory or not. So all of this is transferred through the internet to a computing service, and that is where all the analysis, data storage, everything happens. So
once you talk about transferring data through internet, cyber security becomes an important factor. So all this data security has to be also a part of this. Now the last one,
most of us are aware of, is the robot. So you would have seen
cars being manufactured by larger robots. So they just robotic arms are automated tools that are programmable. Actually, they know how to pick up a part, how to assemble it, and how to transfer this product to the next equipment. So all of this put together is then industrial robot, and most of them have three-dimensional movement. They can move from this to this direction in all three directions. So three-axis movement are typically a part of a robot, industrial robot. Now, the last thing is putting everything together is this. Now all the components of a cyber physical system, we have seen it. Now, what is when you put all of them together, we get a smart device or a smart setup. And when it comes and is being used in a manufacturing setup, it becomes a smart factory. So why do we really need all these technology? Now we are all aware that we need a lot of devices, we need a lot of things, a lot of material comforts. And with increasing human population, this demand is going to increase now. And we have a natural resource crunch, mean, resources used to make the devices, make the material that we need is dwindling. That's a natural thing. All of us are aware of this. So, and from an industrial perspective, they also want to reduce the cost, but at the same time, they cannot compromise on quality. Otherwise, nobody will buy their product. So all of these, when it's come at the same time, there has to be an optimal way for anybody to manufacture materials or products, and it has to be sustainable too. I cannot keep on using resources and waste it. So when all of this has to be brought together, I cannot say I will not use the material. That is not possible in a developing country like India, or it's not possible in any part of the world. So when that is, both have to be balanced, there has to be a smart way to integrate the technologies together and give a quality product. So that is what is driving this industry 4. So when it as a student, how do I look at this? What are all the opportunities available to you? When I've been describing each component, you can easily understand this is not a single arena. It has multidisciplinary approach, and it has a lot of avenues open to it. And it's not just restricted to one industry per se. You can use this in an agricultural field. You can use it in healthcare. Nowadays, a lot of these tools have been used in healthcare to a greater extent. So in every aspect, every field that you can think of, all of these technologies have come into play. And this is just to give you an idea. There are estimated that 3.7 trillion is the value of industry 4 that is expected by 2025. So now with this background, I think you can imagine what are all the avenues available for you. You can think of doing a course in any of this related thing, and you will have multiple opportunities available. So what is the main difference between what is there today or industry 3 and industry 4 is the data-based manufacturing. So all these things were repetitive tasks. All that you have to do is an easy task when it comes to engineering. Now you have to monitor the machine, error detection, decision making. So when you think about it, much of this needs a skill set where you can think on the spot, and more than mechanical job, you'll have to use knowledge. So knowledge has become a much more valuable now. It's become a valuable commodity, and ability to work with data is a tremendous skill that you really need. So all the skill sets, like knowledge about different aspects of technology is one thing, but how do I really deal with the information that I get from it? Can I make useful prediction out of that? Can I make sense of the data that I get? That is important skill set that you need to know. And I will have to be adaptable. When it comes to a personal skill, I have to be adaptable because technology keeps changing each day. So that means I have to make myself adaptable, so I can also understand each technology and then go with the flow. Now I will just leave with this thought. Now we have talked about industry 4, which is already there today. What happens to the next generation? I mean, within few years, it is predicted that we will move from industry 4 to the next one, no matter what it's called, industry 5 or society 5 or whatever it is. That is being thought as an inclusive and more customized manufacturing. The way I think about it is the natural evolution from industry 4, where all of the information has been got and you customize the product. Instead, you give the control to the customer themselves. They can see how the products are being made. So a lot more customization will happen in the future. And also sustainable development goals will play an important part in future industrial growth. So with that, I will stop, and I'll take any questions if there is.
Thank you. Thank you very much, Dr. Sindhuja, for such an enlightening talk, and especially because your talk correlates with what are the requirements of industry. So especially because the school students, they may not be very well versed with what is happening in industry right now. But as they are our future leaders, so it's important for them to understand the do's and don'ts and which are the areas they should strengthen upon during their uh, the school time itself, and which can help them later on in their career. There are a few questions. I'll take up one by one. The first one is, I think that's a very basic question that can you explain augmented reality and precision engineering in detail?
I might really run out of time, but
Okay,
yeah, I'll
just
just try
yeah,
to put it in a simple words if
yes,
I can. So augmented reality is nothing but visualizing something for, and also having information related to that. Now I have a say I have a house in and I want to know what is inside the house, what is the temperature in one part of the house. So now if I have a visual image in front of me, there is the tool that, like the goggles that you saw, there is the tool that can give you that information as a three-dimensional image for you. And it also tells you in one part of the room, your temperature is this much, and one part of the room, this is the chair is there, one part of the room that you have a table of this size. So that visualization of what is there, that is the augmented reality. I'm putting it in a very simple way, not going into all the technical details behind it.
sure.
There is a slight difference between what is that and a virtual reality. Just wanted to point that out. When you play a virtual reality game, you tend to move things around, and you try to simulate with that. So that part of it is not really here. It is a reality on which the digital information is superimposed in augmented reality.
Okay, I'll take up the next one.
So
What is the
I'll
role
post
of
it.
mathematics in
Lot of
technology?
lot of it,
Yeah,
because each of the tools, statistics and mathematics, play a huge role when you have to do any analytics. So mathematics is the basis for most of them.
okay,
So though many in industry may not really have to know all the mathematics behind the tool they use, but knowledge of that will help them develop the tools much better.
okay. I'll take up the second last question. Is artificial intelligence beneficial from employment point of view? And the second part is, can AI create unemployment?
It will not really create unemployment for sure. The way we are used to working, that is going to change for sure. If the things come up in the same kind of a speed that is there today, then definitely the environment in which we will work and the way we work will change. But again, as I said, you will have to have a different kind of skill set to work with an AI. That is the only thing. I'm sure much more opportunities are going to open up if you have the right skill set, because you need to there are a lot of data that is coming in, lot of equipments that need predictive analysis. Whether you're doing a traditional engineering course like a core, or you're going to an IT related field, it has a lot of opportunity. I'm sure it is not going to throw anybody out.
I'll take up the last question now. How can we distinguish between applications, whether it uses IoT or artificial intelligence?
Well, IoT, when I say, it's just a sensor with the way and it has a mechanism, like a sensor with Wi-Fi or a Wi-Fi connection built into it. That's just a simple way to think. That's it. So even your smartphone will have an IoT built in it, because it gives you the GPS coordinates. So when it comes to AI, it is the set of tools or the computing tools, like a program that tells you what to do with data, or what to do with when you are analyzing a situation, just as in a simple way. So both of them are completely different.
Okay, let me just check the chat section once again.
Yeah.
Yeah, so I've taken up nearly all the questions. So thank you very much, Dr. Sindhuja. And on
Thank you,
behalf
Professor.
of the National Academy of Sciences India Delhi chapter and the Indial Upadhyay College, I would like to thank you once again for sparing your valuable time and sharing your research expertise and knowledge with the students. And I also would like to thank all the students and the school teachers who are there with us for this webinar, and hope to see you all again on September 13th for another interesting webinar, and the details I'll be sharing with all of you subsequently after this webinar. Thank you very much.
Thank you, Professor. And
Thank
thank you everyone for your patience listening.